groups. Welcome to the working group. It's a little bit smaller than most of our working groups, but it is an important subject, and it is. I've given talks like this before, but this is a little bit different. And let me go ahead and just bring this up so that you can see the PowerPoint. There's a lot of interesting slides. This will be available as a PDF afterwards, and there is going to be a recording of this because sometimes people want to see it, but they can't make it for some reason in the afternoon. So anyways, that will probably be available as well on our website. So let me go ahead and bring this up, share, get this started here. 1 minute here. There we go. Okay. So you should be seeing a screen with a picture of the Sparks Industrial Area, and the title of it is the Forecasting the Extent and Magnitude of Flooding, the Windware, and How We Will Know of Large-Scale Truckee River Floods. And this will, I think what we'll do is I'll just go through this. If there's some real clarification question, go ahead and just put your hand up, digitally, and I'll answer it. But I think afterwards we can also have extended questions. I just got a flash from the Weather Service. They are saying tomorrow and the next day they're going to have briefings about atmospheric rivers. And so I am going to be talking a little bit about atmospheric rivers today. So with that, I'll just keep going through this slide deck and explain some of this stuff to you. So here we go. The purpose of this talk is so that when you're done with it, you'll get an idea of how often does the Truckee River flood, and yeah, it does. How will I know when a flood is coming? How do you decide if there's a real problem or not? And how can I figure out if the flood may or may not affect me? You will have techniques, information to be able to answer all these questions and be able to deal with that. That doesn't mean there isn't some follow-up work to do, but at least you'll know which way and what direction to go to be able to answer all three of those questions. So the first question is, well, does the Truckee River flood and how often? And it does flood quite often. We have been fairly fortunate. We have not had a large flood over 10,000 CFS since 2017. And we haven't had a really large flood since 2005. But if you look at the history of the Truckee River, you can see the 1862 flood was a very big flood, although Reno wasn't very developed. There was no gauge here. We don't really know how big it is, but that flood in Carson Valley was devastating, and it was also devastating in the Central Valley of California, where several cities were wiped off the face of the map and never came back. So it was that kind of a flood. It's probably bigger than anything we've experienced since. Now, if you look along here, you can see in green and yellow, these floods are all over 18,000 CFS at Reno, and that would do significant damage. We're talking a flood of that magnitude is going to do at minimum $700–800 million worth of damage in the Reno Sparks area. And you can see that's happened 1, 2, 3, 4, 5, 6 times since 1907. So 6 times in the last 100 years, 120 years, we've had this. And so this is something that we have in this area. The Truckee River definitely can flood, and it can happen back to back to back. Like if you look at 1950, you had 19,900. Then the same year, you had another one. Then the 5 years later, you had another big one. So it just goes on and on like that. You can have them back to back, or it can be several years in between flooding. Like from 19 37 all the way to 1950, there really wasn't much of anything. That was a dry time, not very much flooding. There's been a fairly dry time really since 2005. We've had some floods, we've had some big water years, but fortunately, these water years have been cold water years. Cold meaning it fell as snow and we didn't get the big flooding from it. So, some things that have happened in the watershed, Lake Tahoe Dam, Martis Creek Dam, and a bunch of other dams in between. These help regulate the flooding and bring down these levels later compared to these levels. I mean, according to the Army Corps of Engineers, if the January of 1997 flood happened without all this regulation, it would not have been 23,000. It would have been around 45,000 CFS, about double. And the damage would have been catastrophic, beyond, it would have been, in the national news. We would have been North Carolina. Okay. So it would have been terrible. But these dams and the regulation and things like that have helped bring this down a bit. But even with these different dams being built, etc., what I want to show you is that since the last dam was built, we've had 1, 2, 3, 4 large floods in the period of about 40 years, including what we call a 117-year flood, a 70-year flood. This flood was about a 50, but at Vista, because of all the side tributaries, it was actually a 100-year flood. So, buyer beware with these exceedance probabilities where I say X 100-year or X 50-year, that thing. The problem is we don't actually, if we redo this, it might be a little bit different. This line for the 100 might be going up a bit because we have gotten 4 of these larger floods in the last 40 years. So that's just something to think about, even with all this regulation we have now. So some patterns, once again, since 86, less than 40 years, we've had 4 damaging floods. Another big one is, if you look at when these floods occur in the seasons, all of them have hit from mid-November to late March. So, is there a chance that the Truckee River could flood in June? Sure. Not a very good chance. You always have to worry about flash flooding any time of year. But in terms of big Truckee River floods, it's probably going to happen in that window from late November or mid-November all the way through March. And if you look at this, if you look at all these dates, they're all in that time period of all those different floods. They're all in that from November to March. And the other thing to say is, like I said, 4 big floods. Look at that recurrence interval: 50, 117, 70, and 40 in a 40-year period. I don't know about that. Probably these are, maybe that 117 isn't really a 117. Maybe that's a once every 75-year flood. Maybe these are like once every 25 years, things like that. When we go to design our flood mitigation, for instance, I'm trying to go bigger than just what we call the 100-year flood. I want to go bigger because I don't want to be taking have a big flood and then we get wiped out, even though we put in all this mitigation work. And so it can hit. I mean, these are a lot of different floods in a short amount of time. So this brings to the next point. Okay, we know we get flooded. We know how often we get flooded. We tend to have a significant flood if you just subtract the number of years by that. A significant flood every 20 years, something that does damage, something that gets out of its banks, something that puts water in the industrial areas and in the airport. About every 20 years, we get some sort of flood like that. Some are worse than others. So how do we know if a flood is coming? You know, how do I know? I'll tell you how I look at it first, and then I'll tell you how maybe you can look at it to kind of get an idea if something's up. So first of all, when we look at this watershed, the Truckee River watershed, we have to understand there's a large lake in the middle, Lake Tahoe. It's regulated. It has a regulatory dam, and it can regulate about 7 feet-ish. And so that there's a lot of storage there actually, and that can help us with flooding. There's also other dams like Stampede, Boca, Martis, which isn't fully functional, and Prosser and Donner. So there's these dams and their storage. They can also help. So there's a lot of attenuation by reservoirs. There's multiple climatic biomes. We're up in, beyond the tree line up in here in the Sierra Crest and in the Desolation Wilderness area. And yet we're down in the desert here. We're rural up in here and over in here, but we're urban here. So there's just lots of diversity and things to look at in this watershed. So when we start to think about that, we have to understand that we are dealing with a complex, integrated, large watershed with lots of different things going on. And so one of the ways that we deal with this, and NOAA, National Oceanographic, et cetera, NOAA for weather, they have a river forecast center, and they have a model that tries to incorporate much of this variability all in and predict what the flows will be. Is it perfect? Is it awesome? No. Is it better than anything else we have? Yes. But the idea is that we have a staff of people in Sacramento that are trying to predict river flows all up and down California and Nevada. And this is one of the critical ones. So what do I look for before a flood? I'm looking at when I'm concerned when all the reservoirs are full. I'm concerned when Lake Tahoe is up near the rim of its where it can be, and there's a legal limit to it. If it's up near there, that means we don't have much to play with. I'm concerned when all the reservoirs are full up to their flood storage. I'm also concerned when there's a lot of snow on the ground, especially at low elevation, because we can get rain on snow. And I'm also concerned if there's recent storms that have saturated the ground. Those are factors that, before a storm make a difference in how the storm will hit. But most of all, I'm very much interested if there's an atmospheric river in the forecast. I guess I could have put quotes around that, but that term and that situation is associated with almost all the flooding that we've ever had on the Truckee River, one way or the other. A lot of times before that, it wasn't called an atmospheric river, might have been called a Pineapple Express. It, obviously, different terms over the years, but we've kind of come to that term, atmospheric river. And so the 1997 flood had a series of atmospheric rivers. The 2005 flood, atmospheric rivers. The 86 floods, Pineapple Express. They didn't call them that yet, but that's what they were. So atmospheric rivers are a big deal. And honestly, the science behind it and why we are so vulnerable to it and why it's such a big deal is there's so many kind of like the perfect situation to set us up for it. For instance, an atmospheric river moves like a conveyor belt, like this. You can see this blue line coming through. This is a conveyor belt of water vapor coming off the Pacific Ocean. So it comes around a low pressure system, and it loops around counterclockwise, and it's just coming and coming and coming. So you have a gigantic cyclonic situation with a low, with this water just coming, and it doesn't even come in fronts. It's just a stream. And the amount of water vapor that's in there is sometimes bigger than the Amazon River at flood stage, or definitely bigger than the Columbia or the Mississippi River at flood stage. It's a lot of water, but it's coming as vapor. And when this vapor hits the California coast, it rains in the Bay Area, sure, but then it lifts on the Sierras. And when it lifts, if the storm is warm enough, it's going to remain as rain, but it's going to rain hard because there's an orographic effect, a lifting of the mountains, lifting that water up, cooling it, causing it to condense and form droplets in rain. If it cools enough, it's going to be snow. And so that creates a whole different kind of problem, but not a flooding problem, at least in the short term. So these things have been called atmospheric rivers. They've been called Pineapple Express. They've been called conveyor belts. And I also say, note, they're the largest freshwater rivers on Earth. They're up in the sky, they're vapor, but in terms of volumes of water, when they're going, they can have more water than any river, including the Amazon. So when I say Pineapple Express, that's what we used to call them in Oregon in the 80s and 90s. You get some scary thoughts because what happens with a Pineapple Express is the snowpack has a level of coldness to it, a level of lack of heating. And when a snowpack gets ripe, that means it's heated up and it's ready to melt. But what a Pineapple Express is, it's not just rain, it's a bunch of water vapor. And so this water vapor gets over the top of the snowpack, and the water vapor begins to condense on the snowpack. And when you have water changing from vapor to perhaps liquid water or even ice, the amount of calories that's released is huge. And that goes into the snowpack, and that energy can melt, turn ice into water. Turning white ice into water is only like in the 70 or 80 calorie range. The amount of energy that's released turning water vapor into water is 540 calories. So you've got basically an order of magnitude energy release into the snowpack to melt it. And that's why a rain on snow, if it's warm enough and you have warm vapor like that, can actually melt a snowpack way faster than a sunny day, even if it's relatively warm. That's what's so dangerous about this and scary, if you will. And when I worked in Oregon as a hydrologist, I mean, this is the stuff we feared. I mean, we're just like, oh, great, we've got a snowpack with 20 inches of water on it, and we've got a Pineapple Express coming. And this is what they look like in the sky, from satellite. Here's the low, and it starts spinning this stuff at us. And it just comes. This is a California AR, but they actually happen in Oregon and Washington, Northern California. All along this coast here, they happen. And the thing about California is the Sierras are so pronounced. I mean, you have 14,000-foot mountains, 12,000-foot mountains all over the place, especially in the Southern Sierra. Oregon doesn't, the mountains aren't quite so high. There's a volcano here and there, but it's not as high. But it's bad. I mean, you still get the orographics, but not like this. So when these things spin in, you get all this water conveyor belt of water vapor coming. It lifts here, and then you get tons and tons of either snow or rain. Hopefully snow from my perspective. And this is just an example from Oregon when I was the forest hydrologist up there. This is the 1996 flood. It was a massive flood. It caused all kinds of damage, killed at least 12 people outright during the first event. And it had 4 distinct peaks. And you got, like in this location here in the Coast Range of Oregon, you got roughly 19 inches of rain. But what this graph doesn't tell you is there was about 15 inches of snow water equivalent. That is, the snowpack on the ground had about 15 inches of water in it. And after this storm, that snowpack was gone. So now this 19-inch storm turned into a 34-inch storm. And the results were devastating. There were landslides, There were hundreds and hundreds of culverts blown out. There were debris flows everywhere. Um, and, you know, hundreds of millions of dollars of damage because of this basic premise of a four event, four atmospheric rivers with four peaks and four, there was like 7 inches in this one, 5 inches of this one. And sometimes it was running up to 0.7 inches per hour when it was going. And then all that water vapor was melting the snow. And this is what you get. You get just a catastrophic event. So when I talk about what's possible around here, I am not a meteorologist by trade. You might think I'm just a flood engineer or something, but I am actually a hydrologist. And if you look at this, whoops, sorry about that. If you look at this, what is capable here? Well, in December of just 2021, it snowed at the Central Sierra Snow Lab. It was a all-time record, and I think it was, I can't, here I got to say, okay, over 200 inches. It was the all-time record for December. And it had 68 inches, and this is at around 6,800 feet, 68 inches in 48 hours that in the Sierras. The next month, it was completely dry, by the way, the whole January. Then the next year, we had in the south area, like down by Mammoth Mountain, Mono County, that area, a all-time record snowpack. We had the re-establishment of lakes that had been extinct. Ghost lakes came to life in California. Lake Tulare and other lakes came back to life that year, the very next year. So, these are just in the last few years. And we were fortunate because it was a cold winter for us, and we didn't have it all melt off, or we didn't have what we call Pineapple Express. It was a colder AR, so we didn't get a bunch of rain. So we were fortunate. But that's what we're capable of. If this is 5 degrees, 4 degrees warmer, we would have had 97 flood. And same thing in 2017. If we would have had a few degrees warmer, a slightly different trajectory, we would have had the 97 flood. So every year, the people up at the Weather Service up there north of Reno, or me or others involved, are sitting on the edges of our chair wondering, okay, is the trajectory going to change? Is it going to get warmer? Are we going to have a problem here? Because we don't know until it happens. We have some ideas, we have some concerns, but we actually don't know. And I'll show you this in a minute, what will happen until right before it happens, a few days, maybe even hours before it happens. So another one here, off the Mount Rose Highway, 4,700 CFS. That is like a small flood on the Truckee River on a small creek. And that came through in 1957, and it was a massive flood. And that was a flash flood. So, that's what these things are capable of around here in terms of precipitation. The 1862 storm was a series of ARs that went on for a month. And we had the Central Valley wiped out. We had massive damage in Carson Valley, etc. Much bigger storm than what we've seen here lately. So the question remains is, okay, that's what can happen. How do we know if it's going to happen? Well, the way I do it, if I've got a concern, if I think I'm seeing ARs coming, I go to this River Forecast Center because they have the large scale model of the whole watershed. And it's the best information that we have available. And we have done studies to look at, well, when do things really break out and we have problems with flooding? And we correlate that to the stage at the different gauges. So like the Reno gauge, stream flow gauge, the Vista Narrows stream flow gauge. And when this is 15 feet at the Vista Narrows gauge, we start to really actively monitor. And if it's at 17, it's flooding. If it's at 18.5, uh-oh, it's getting pretty big. And if it's over 21 feet, there's going to be millions and millions of dollars of damage locally. So we want to know forecast wise how big a flood is going to get. And this particular website can give you for many different rivers. And I mostly look at the Truckee River at Reno and Vista and Steamboat Creek at Steamboat because I'm interested in the Truckee River because of my job. But there's for many different rivers, Carson River, Walker River, all these different ones, they have these forecasts. And so the forecast looks something like this. Now, this was taken yesterday. I put this in and it looked like, not much is going on here. We're going to have some rain over the weekend. Looks like it might elevate a little bit. This is not much at all, really. I mean, I said 15 feet before we actively monitor. I mean, we're only getting up to 5 feet or 6 feet. We're only getting up to 1,000 CFS at the most. Maybe up here, real unlikely, 2,500. That's still not bad. It's really not bad until you get up around 15 feet. And so this is nothing, right? That was a day ago. Now suddenly we're having AR updates tomorrow. That's how fast things can change around here. And the closer you get to the event, the more accurate it's going to become. And within a couple of days, it's pretty accurate. But 10 days out, 5 days out, it's not very accurate. So all winter long, we're just kind of checking in, making sure, that kind of thing. And that was, that didn't show much. But let me show you something here. This is from 2017, a flood this was an actual flood. It did cause some moderate damage, not super bad. But, looking 10 days out, this is what it was predicting. This blue is what actually happened. This is what it was predicting in green. So 10 days out, not so good, right? Not a very good thing. Even the actual thing, the actual prediction of the meteorologists, etc., that kind of overrule it and make sure that they're capturing things, they weren't seeing much either. They missed this little peak thing, although some of the probabilities said there was a possibility of it. So not much going on here. But watch it when you get real close to it. This is just a few days out, 3 days out. Look at how accurate the Weather Service meteorologists were and hydrologists were in predicting that peak. Pretty close. And even this was coming up and these probabilities were showing things. And that's why you have to stay on this and keep watching, because these atmospheric rivers are unpredictable, and not unpredictable, but they are hard to predict. And so you really have to stay on them and watch them. And like I said, when you get a couple of days out, it actually becomes pretty accurate. And they get the trajectory right, temperature's tough, but they start being able to see these things, see these problems coming forward. And now we're like, uh-oh, this is going to get up and get out of the banks and cause some damage. So now everybody's alert. Maybe an emergency has been called around at this time, somewhere around here. We're going to be calling an emergency, etc. And we did in 2017. So the next question would be is, okay, so it was way up there. It got up, 18, 19 feet. What does that mean? What does that mean in terms of the floodplain? What gets covered? Well, in a 100-year event, all this area in blue is going to be underwater to some degree, different depths, some really deep, some not so deep, but all this area is underwater. That includes much of the industrial area in East Sparks. That includes some of the area in West Sparks. That includes the area down in here and in the Reno industrial area. It includes parts of the airport. So lots of areas here are underwater. Hidden Valley, areas off of Pembroke, areas in here where the golf course used to be. All this area is apt for some level of flooding at the 100-year event. Now, for a 2006 event, it's less. You know, some of this area is not getting flooded. Looks like the industrial area is fairly dry. So it wasn't so bad here, right? In this case. And it's important to kind of know exactly what kind of flood you're getting into. If it's the 100-year, then I got to really worry about it. If it's the 50-year event, if it's lower, I'm not going to have as much of a problem. So it's important to know what kind of flood we're expecting and what kind of where you are at in the floodplain, what kind of damage you might experience from the flooding. So these are the kind of questions we can now answer, or at least give you estimates and reasonable ideas about what's going on, which we really couldn't do maybe 15 years ago. So just an example, this is a barn right near the Truckee River, off Mill Street. That's rock, that's McCarran. But anyways, if you look at this, this is on a Ferrari Farms, if you guys know where that is. And you can look at that and you can go, oh, okay, well, that's interesting. I wonder how deep that'll be. I wonder if it'll get into the floorboards of whatever structure, you know, how high off the ground is that? How deep is the water? Do I have to really worry about it? Is there something I can do? Can I put some sandbags up and do something about that? Now, with the detail of the modeling we have, look at that. I can actually tell you how deep it is around that. I could change these to elevations and tell you what the elevations are, and you can compare that to your floorboard or whatever you have there. You can see right here it's dry. So it got dry there, but over here maybe some water's trying to creep in on that side. So you get a better idea of what you're dealing with, and the detailing of this helps a lot. And remember, this is the 2006 event, which is smaller. If it's the 100-year event, this is all going to be much deeper. And if it's bigger, even it's even deeper. So different kinds of floods, different kind of effects, but the detailing of the model, we can get right down to the point. In fact, if a truck wanted to get in here, I can run this cursor along in the model and tell you how deep the road is all along here. And this is based on LiDAR points that are, only a foot or 2, 3 feet apart and are accurate to sub 1 inch, quarter of an inch actually. So this is very accurate information, and I can tell you what you might expect there if that water is a certain level or if that flood is a certain height. These are things we can do now. So we don't just have depths and ideas about one flood like the 100-year. These are the flood levels we've looked at for first responders. So they have an idea for different kinds of floods, what they might expect. And there's maps for the whole area for these. And there's a model for each one of these. So I could get in, tell you the velocities you'd expect, tell you how deep it is, tell you what elevations they are at given points. So that's all doable now. And the idea is when you see a certain flood coming at you, like the 2017, and you know how big it is, I can say, well, that's going to be really similar to this flood right here. So let's look at what this flood right here was in terms of depths on these maps. And if you need some more information, let's go into the model and find out. And by the way, I can actually take this flood and do a custom model and map it to the custom storm. And then we know if we think this thing's going to happen on January 8th at this time, I can tell the first responders, hey, we just ran this thing. I ran it right here. And in a day and a half, it's going to be up to this level. So you really want to get out of here probably by, Sunday morning at 12 a.m. Or don't go past this time. Now, we're not going to get all this exactly right. These models are not 100% accurate, but we can give people some ideas about what they're up against and what they're going to be facing in the hours ahead or the days ahead. Can't really do it weeks ahead, but we can do it days and hours ahead. And the county also has a flood action plan, and that's how we decide as a county what level of flooding we're having. Do we call it an emergency? Do we, say overtime's okay and, try to get federal funding, all that kind of stuff. We have a decision tree for this. And it's really based on that, what the stage is at these gauges. These are major flood, moderate flood, flood stage, action stage. That's at Vista Narrows and the Reno gauge and the Steamboat gauge. When we see these things, this is when we do different things. We start doing more monitoring at the action stage. And if we think it's going to get into moderate flood stage, we might even call an emergency. It's just a matter of what we think is going to happen. And this is showing the plan resources at different action levels. You can see as it gets bigger and bigger and bigger, which is the stage at a given streamflow gauge. These are the kind of things we're going to look at. But the mapping that we have at TRFMA can actually get very specific for a situation like, can we get down this road? Or if we're going to go down this road, do we need a boat? Or do we need a high axle vehicle? Or do we need just a regular old truck because it's only 6 inches deep? That's the kind of things we can get into with the information we have now. And, obviously it's not perfect. It's not a perfect prediction, but we can start to get at those kind of issues. So this comes down to, okay, that's great, you guys at the county and cities and fancy dancy modeler. That's wonderful. What about me? How do I know when I might have a problem or not? And the basic thing is there are tools and information available. This is not the only, but this is a good one. And it's commonly available and it's free. So you just go to the Weather Service. You just go type in Google Weather Service Reno, and boom, this comes up. This page right here comes up, and you go, oh, this is the weather for the next few days. Uh-oh, something in red here. What is that saying? That is saying wind advisory in this case, but it could be a flood warning, um, a flood advisory, or a flood watch. And when you start seeing that, when you start seeing flood advisory, flood watch, flood warning, you know that something's going on with the Truckee River. And usually they will actually have commentary on it. So that's the first place you could go to find that out. And most people use this. So when you go skiing, you want to know what kind of clothes to wear at the ski. If you're going fishing, you're going to want to know. If you're going to go for a hike, you're going to want to know. So people use this resource all the time. But here you're seeing, okay, uh-oh, flood warning, flood advisories, flood something, flash flood warning. So what do these mean? If it's a flood watch, it means be prepared. It could change. Something could change here. This was from 97, and this is over near Hidden Valley, but where the golf course was along Steamboat Creek. And you can see how high it got. But it's, before this came, a flood watch came out. And it's like, hey, we're going to have a flood watch. Could be bad. We're not sure yet, but the conditions are favorable for flooding. Then you can have a flash flood warning. This is another 97 photo of the island up there with the farm there, the farm there over off of McCarran and Veterans Parkway, which wasn't there at the time. But for flash flooding, it's at the mouths of these canyons, along creeks, etc. If you're living along a creek like Galena Creek, Whites Creek, these kind of things, if it says flash flood warning, what I would be doing, and I didn't get into this and really lay it out, but I can if you ask me, if you want to do this offline. But you look at radar, and if you see radar, if you see yellow and red radar heading for the area upstream of your house, you may want to take some action before it gets there. Because by the time the gauge comes and the stream flow comes, your house is already wiped out. Those things happen in a matter of minutes and maybe an hour at all. But you can see forecasts of radar showing, oh, there's going to be a band of very intense weather coming your way. And that can happen any season, flash flooding. So that's a flash flood warning. And like I said, these areas, Galena, Hidden Valley, Long Valley over by Lockwood, these are areas that are very susceptible to flash flooding. And almost any of these little creeks coming out of the mountains, jumbo grade, there's plenty of them. I can't list all of them off the top of my head, and I'm not going to. So what about the flood? Well, flood warning's the worst for the Truckee. That means it's imminent. It's going to happen. Probably very strong chance. Maybe you need, if you're, depending on where you are, you may not have to do a thing. But if you are in the floodplain and you called me up and you said, hey, if there was a big flood, how deep would it get around my house? And I said, oh, it's going to get about 6 feet deep. Well, then you might want to leave. Not might, you do want to leave. But you can find those things out ahead of time and kind of get an idea of what you're facing with a different kind of flood. I can even tell you, oh, if Vista Narrows is doing this, watch out, and you could literally look at that hydrograph predicted from NOAA Weather Service and go, hey, it's going to get up to 17 feet. It's 17 feet. George said that I'm going to have water in my garage. So I better put some sandbags up. You can start to be able to do things like that with the information you have in hand. And many of you just don't even have anything you got to do, but maybe the road you want to go down is going to be flooded. These are things you can find out ahead of time. So finally, there is flood advisory. That's kind of a step down from a flood watch. And by the way, this is the Booth Street Bridge in 1907. So you can kind of see what it looked like way back when. The flood advisory means, things are possible for flooding, and you might want to keep an eye on things when they issue those. So if you are in a flood watch or a flood advisory and you're concerned, and the news is even talking about atmospheric rivers and saying things like that, there's one that's going to go probably through the Reno area, then you can literally go to this, and anybody can, it's free, the River Forecast Center, California, Nevada River Forecast Center, hit that, go to it, and you can get those hydrographs like I had. And it's rather easy. If you want some help, come on down, I can show you. I don't, especially for people that have a lot of property or holdings in a floodplain, it behooves you to do something like that. Knowledge is power in this case, if you know what you're up against. So, that brings up the question, well, how do I know if I'm in a flood zone? Well, it's fairly easy right off the bat to get a rough idea if you are in a flood zone. It doesn't say how bad you are in the flood zone, but you can find out if you're in or out quite easy. For instance, if I want to know if I'm in a flood zone, by the way, this is Wadsworth, a trailer park there in 1997. This is not the high point of the flood, by the way, but you can see it's like right up against there going into this trailer park. So anyways, the first step, you can go to this website, and remember, this PDF is going to be saved. So if you want to get this address to go to, you can go there, and it says FEMA Map Service Center. So you hit that, then you just put in your address and you go search. And then, so I searched my office, boom, there's my office. Guess what? I'm not in the 100-year floodplain. But what if I was here? Or what if I was over here? Then I want to kind of know, okay, well, how bad am I in zone A? Like, how deep does this get? You can't get that from this. You have to come and look at, maybe you have to ask me or somebody like me with the modeling and with the greater information. We do have flood maps with depths for different kinds of floods. You could do that without even talking to me off our website, or you can come in and go, okay, here's my house. It's in the floodplain. Where is this floodplain? Go there. Okay. Uh, Pull it up in the model for the 100-year. Oh, you're 3 feet deep right there. You're at elevation X right there. What's your floorboard elevation? Do you know? See, you could do stuff like that very quickly and easily. So once again, if you're in this area, this is where you want to be, try to get more information. If you're looking at, what could you do about flooding, I suggest if you are in a floodplain, you figure out where your house sits. If you're in an area that's prone to flash flooding, like along a creek or something, or you suspect it, you figure out where your house sits and what kind of vulnerabilities you have. And then you figure out what you should do if you get into this flood watch, flood warning business. Like, do you do sandbags? Do you evacuate? Is it, oh, well, yeah, I'm in the floodplain, but I'm barely there, and this isn't a very big flood. There's a lot of different responses depending on the circumstances. And so for people that are in the floodplain, which apparently there's only 7, these are the kind of things that you can do. And, if you know friends and stuff that are in floodplains, encourage them to look at this PDF so that they can get more information and figure out what kind of vulnerabilities they have instead of being surprised by it during a flood. So that's it for my presentation. So I'm open for any questions about anything. And I'm going to stop the share unless somebody wants to look at a slide. Does anybody have any questions? Do you see any hands up? Matt has a question.
Go ahead, Matt.
Hi, thanks for the information. I'm curious how you handle in the modeling the management component of reservoir storage. For instance, prior to the 97 flood, we had 15 days where we were dumping all the water out of every reservoir we could and maximizing that based on how much we could fit through downtown Reno. Um, that the issue there becomes how much snow moisture storage capacity effectively we have below the reservoir. So the component that we can capture and the component that you can't manage for. How are you guys handling that in your modeling? And then kind of the second question is along the same line, and that is understanding in a model that when we only have these large historic data sets to go on, how do you kind of divvy up the timing of that from flooding that occurs from essentially the Steamboat watershed into the Truckee Meadows versus the Truckee River watershed into the Truckee Meadows? Like for instance, the airport initially flooded in 97 from Dry Creek, not from the Truckee River. It was later flooded from the Truckee, right? How do you guys handle those temporal and spatial differences in those when you're evaluating the atmospheric rivers?
What we basically do is we're taking what we receive. Like if we're going to there's hydrologic models, which are typically less accurate than hydraulic. Hydraulic is typically very accurate, if the hydrology is right. And then even less accurate is meteorological modeling. So we got meteorological to hydrologic to hydraulic. So what we're doing is receiving the hydrology, and these hydraulic models have multiple input points. So we can have a dry creek component. We can have a steamboat component. We can have a North Truckee drain component, Long Valley Creek, Dog Valley Creek, those kind of things. We could do that or might do that if it looks like the storm has a weird pattern to it, or maybe it's going to be all snow in the Sierra and really the whole output is going to be from these lower elevation areas. So there's considerable engineering judgment that would have to go into that if we're customizing something based on, oh, this is a weird one, because 86 actually was kind of like that. The 1986 flood was, a lot of it was coming from the lower end, was coming from the Dog Valleys, was coming from the North Turkey Drain and Steamboat, etc. It wasn't really coming off as much from the Sierras. It was an event, sure, but not not a 100-year event. But those little tributaries were really producing a lot. And so we have to make those judgments on where the storms are centering. And with the information we have now, we can look at forecasts and we can look at the radar and what the patterning might be. We can also look at temperatures and go, you know what, this is going to stay snow up high, so I'm not really caring about the generation off the Stampede Reservoir watershed right now. Plus, they can probably control it at the reservoir. You're making a lot of judgments like that to get to there with the hydrology. Hydrology is more of an art, where hydraulics is more of a science. It's more exacting. You can calibrate really good and get down to it, but the hydrology and the meteorology is tough. And that's why, I mean, you want to have people that have some experience with this stuff trying to figure this out. And the river forecast centers people do have seen several things. A person like me have seen a lot. So we try our best, but it's not going to be perfect. I don't know if that helps you, but that's basically some of the things we do. And honestly, we're receiving that model, and that model is adjusted empirically as well. That thing is adjusted based on what's actually coming out of the reservoirs versus what the model is saying should be coming out of the reservoirs. So there's adjustments being done on the upper gauges as they get those readings. So there's a lot of tinkering going on to try to get it more accurate. I don't know if that helps you, but that is kind of how it works in a broad sense. Any comment on that, Matt?
Thank you. Yeah, I hear what you're saying. I guess the question I was really having is there any, do you have any sort of scenarios or modes that you run in based upon where we stand with available storage as dictated by TROA operating agreements or anything else? When we were doing the 97 flood, we were just in the infancy of TROA accounting, and one of the decisions that weighed on those reservoir management discussions about how much water we let out of the reservoirs, right? Wasn't
Yeah.
just the discharge capacity of the reservoir, but it had to do with exactly what you're saying, hedging your bets on a hydrologic model in order to make sure that you're not dumping somebody's water that has a right to store it, right?
Right.
So I'm
And
just curious in that
that
sense, do you guys try to predict any of that as far as what the peaking is going to be? Or do you just make assumption of what the storage
that
will?
actually is they're actually, and I can't remember if you're involved in this. I thought you were, but the upper reservoirs, especially Boca, Stampede, Prosser, especially those three, are involved in kind of a reworking of the rule curves of how they operate that reservoir. And there's a push to go to a modeling uh, rule situation instead of using a rule curve. So that gives you a lot more flexibility with those sorts of things, especially if you know there's a big snowpack and you can make up that storage from the snowpack. You can be a lot more liberal in drawing down the reservoir, correct? So there is that aspect now with the reservoirs that they're looking at. They're actually working on an exception to do it with modeling, to kind of experiment with it. And the other thing too is right now the Truckee River agreement, the Martis agreement, for instance, says the Truckee River should convey 14,000. And then below 2nd Street, it says the Truckee River should convey 6,000. So right now, the reservoirs are limited in their releases between floods or preparing for a big flood to 6,000 because of, you know, the fact that there's breakouts and things like that. We're also working on an exception to get that up higher. And if we build the project, by the way, we can even go higher so that in between these storms, we can have a little more flexibility in dumping water to get these reservoirs down for when the peak comes, and we can attenuate it better. So there's a lot of little things like that that are being done in and around how these reservoirs are managed, that they're working on. And I've been on that committee. I'm not a central person on the committee because I'm not a BOR or a Corps or a watermaster employee, but I'm very interested in advocating for that, to have more flexibility. And they're very aware that I am on that. So I don't know if that helps you. That is kind of the future here, is we want to get more sophisticated, use TROA smartly, use modeling instead of just a simple rule curve, and get it to where we're actually helping with storage too, not just flooding, but storage, actually being smart in dry water years and holding more water so we don't draw down too much and then have no water because we're keeping up all this flood storage that we didn't need. So does that help you on that? Because it goes both ways. It's not just flooding, it's storage as well.
No, you answered my question. Thank you.
Okay. All right. Any other questions? You know, I mean, we can go as deep as you want to go. I'm just scratching the surface here to give you awareness of all the tools that are available and the abilities and inabilities we have to deal with floods and predict them and respond to them. You know, our long-term answer is mitigating and creating structures so that we are not so vulnerable to flooding. But in the short term, we have to do this. We have to be prepared, and we have to know what we're up against. Okay, well, I think that's it, unless somebody else has a question. All right, well, thank you for coming. And like I said, tell your friends that are in the floodplain about this the PowerPoint as a PDF and a recording if they want to know, because it is important for people to understand some of the resources they have if they are in the floodplain, or even if they're in an area that's apt to flash flood. And I'd be happy to talk with people. I have done that. I'm busy, but I think this is a priority thing that I should be doing as well. So I hope that helped, and thank you again.
Thank you.
Thank you.
Thanks, George.
Thank you.
Thanks,
All right.
George.
Bye.